Sir.
Yeah, can you see the slides?
Yes, sir.
Okay, great. Yeah. So yesterday we were talking about briefly about the sampling methods. We were talking about we talked about population, census, parameter, statistic. So this, I suppose I did not explain this in the last class. So I was telling you parameter is everything that you calculate with respect to the population, right? And sample is everything that you calculate with respect to a sample. Now, when you calculate the mean of the population, you use the term mu, and the same value when you calculate for the sample, you call it x bar. So what you calculate for the population is a parameter, what you calculate for the statistic, what you calculate for the sample is called the statistic. Similarly, anything that you calculate, say whether it's proportion, whether it's standard deviation, whether it is any of the other standard variate, whatever you calculate, I think, yeah, yes, he's laptop suddenly shut off. I'll be back in a few minutes. Okay, yeah. So, so anything wrong with the, sorry, anything that you calculate for the population is called the parameter. Anything you calculate for the sample is the statistic. Okay, so and these are the standard notations which are used in statistics generally: mu, x bar, pi, p, sigma square, s square, sigma, s, capital N, small n, sigma x bar, 6 bar. So all of those kinds of things. These are standard notations. So just we essentially want to explain what is the difference between population, parameter, and statistic sample. Then, of course, we've gone through these things, and definition of target population we did it in the previous class. Okay, classification of sampling techniques, two basic techniques: probability sampling, non-probability sampling. We went through the 4 non-probability sampling techniques yesterday. The 4 non-probability sampling techniques are convenience sampling, judgment sampling, quota sampling, snowball sampling, right? So we've gone through this. Today I'll take you through sampling. Okay, so probability sampling techniques, there are 4 again in number: simple random sampling, systematic sampling, stratified sampling, and cluster sampling. So like I had actually said in the previous class, in a probability sampling, the choice of the respondents is actually done in a more scientific way, right? So we use principles of statistics and probability to identify your respondents. All right. So there are several ways in which you can do it. The most simple and the basic is what is called as a simple random sampling. So this I was explaining to you the other day. I think Prajwal was mentioning that the easiest way to take out a person in a class of 60 is to put all their names in a bowl and draw lots. And out of 60 people, if you want to take out 5 people randomly, best, easiest, most effective way is to put all their names in the bowl, pick out 5 chits, and that is exactly the illustration of what is simple random sampling, right? Which means every element in the population has an equal probability of getting picked. Whereas if you look at all the other sampling techniques which you used, that is non-probability based sampling techniques, say whether it was snowball sampling, whether it was judgment sampling, or whether it was convenience sampling. Basically, convenience is you are sampling somebody who is at a certain place at a certain time, and you also happen to be there, and therefore you interview that person. So there is no element of that scientific probability. It's not like you're reaching that particular person because he's been picked. No. Similarly, judgment sample, you think that somebody is going to know the answer for that question, therefore you you use your judgment and approach a particular respondent, assuming that that person is going to be knowledgeable about the topic. Similarly, snowball sampling is you reach the first respondent, and the first respondent will lead you to subsequent respondents. I'm just revising whatever we did yesterday, right? I hope you remember, right? And then the last one was convenience, judgment, snowball, and the last one was what was the last non-probability technique? Quota sampling. Yeah. So in quota sampling, you basically ensure that whatever strata or whatever division is there in the population is also maintained in your sample. For instance, 6,000 students in a university, let's say 2000 boys, 4000 girls. So when you take out a sample, you should ensure that this 4000 to 2000, so that, like, twice as many girls as boys. So that is also maintained in your sample, right? So that is the whole thing of quota sampling. Now let's come to let's come to probability sample. 4 different kinds: simple random sampling, systematic sampling, stratified sampling, and cluster sampling. Okay, so simple random sampling, as I said, every element in the population has an equal probability of getting picked, which means equivalent of draw of lots. Suppose you were to do this, another way of doing this is, let's say, for instance, I'm not sure if you guys are aware of it. There is something called as a telephone. There used to be something called the telephone directory, right? So in city of Bombay, if you want to actually randomly survey this people, you can actually randomly take a particular page and pick out one respondent and call up the person and ask for a response. So that is also another example of simple random sampling. So if you want to talk to, let's say, 500 people randomly, take out the telephone directory, open it, go to a random page, take out a random number, call the person and ask for a response if you want to know something about any response of a particular city kinds. So that is again another example of simple random sampling. Now let's look at what is systematic sampling. So under systematic sampling, what happens is you identify the first person in the sample randomly. Okay, let's say, for instance, in a class of 60, you simply pick up the first guy. Let's say you pick up the 23rd guy. Okay, and the next sample that you will pick up will be 23rd plus maybe 10, 33rd. And the next will be 33rd plus 10, 43rd. And then the next one will be 53rd. So 23rd, 33rd, 43rd, 53rd. Then there is no 63 because it's only 60 students, 63. So third. So basically you will be picking up first sample, first respondent randomly. Then there will be a pattern, right? You will be picking up the next 10th guy, or you will be picking up the next 20th guy, or whatever, depending upon what your sample size is going to be, right? So in simple random sampling, all of them are going to be picked up randomly, whereas in systematic sample, the first fellow is going to be picked up randomly. After that, you use a particular interval, every 12th guy, every 15th guy, every 20th guy, or whatever, till such time your requirements are met. Okay, so that is your systematic systematic sampling. Under stratified sampling, what happens is there is a based on gender. Yeah.
The 2 samplings you explained right now. What was the name of the first one?
Simple random sampling, SRS.
So in that, the first person is picked randomly. Then the
all the people are picked randomly. In simple random sampling, all the respondents are picked randomly.
And
which is the classical method of that is putting all the names in a chit in a bowl and picking up randomly.
Second method was?
Second method is called systematic sampling.
In that, the first is picked randomly, and then
first person is picked randomly, and then each additional respondent is picked after a particular interval. Let's say, for instance, in a class of 60, you want to pick 5 students. Okay, in a class of 60, you want 5 students. So what you do is 60 by 5. What is 60 by 5?
12.
12. Okay. Now the first person you pick randomly. So let's say the first person you picked is person number 15. Okay. Then 15th is your first sample guy. Then 15 plus 12. 27 is your next sample guy. 27 plus 12. 39 is your next sample guy. 39 plus 12, 51 is your next sample guy. 51 plus 12 is 63. 63 is third guy. So you take the third guy. Got it? So first row is picked randomly, and next one will be the total population divided by whatever number of sample that you want, and then you add systematically. Okay, simple random is absolutely random. Randomly you pick up guys based on probability principles. This one, first guy is picked randomly, but after that there is a definite interval that you follow and you pick guys like that. All right. Okay. And now let's look at stratified sampling. So in stratified sampling, what you do is you divide the population. I was giving you the example of the university students. Suppose the university students has got typically gender, like I said, 60% girls, 40% boys. So that ratio should again reflect in your sample. So basically, you will subdivide the population into mutually exclusive, collectively exhaustive groups. So girls will be one, like say subgroup, boys will be another subgroup, and you will sample within that. You will use simple random sampling within the girls. Pick up, let's say if your sample is 200, so you will require typically 60% means 120 girls and 80 boys, right? From a sample of 6,000, and if your sample size is 200, so you'll ensure that your sample will have 120 girls and 80 boys. So out of this 6,000, 4,000 girls, you will do a simple random sampling or systematic sampling inside that and pick up those respondents, making sure that that particular, whatever there is a strata as in there is a homogeneity in those respondents, all of them are girls, and the remaining are all boys. So you want those girls and those boys also to be there in your sample. Right, or it could be maybe not in terms of gender, it could be in terms of what their course they're pursuing. Art student, let's say engineering student, science student, commerce student, whatever. So if there is a certain ratio, 20% students are pursuing this, 40% is pursuing something else, 60, whatever, 15 is so that ratio should also reflect in your sample. Got it? So population gets divided maybe by undergraduate student, postgraduate student, doctoral students. So some ratio will be there in that. That ratio should reflect in your sample as well. So that is your what is called a stratified sampling. Okay, and lastly, you have what is called as cluster sampling. In cluster sampling, so if you look at it, these two concepts are quite interesting. The concept of what is stratified sampling. In a stratified sampling method, you will find that within the population, there are clear stratas or there are clear divisions. Let's say, for instance, all the undergraduate students will be one division. That will be one strata. All the postgraduate students will be one strata. All the doctoral students will be another strata. So there are strata within the population, and that strata should also come in your sample. Right. So some homogeneity within it, like we assume that all undergrad students are homogeneous, all graduate students are homogeneous, all postgraduate students are homogeneous, all doctoral students are homogeneous. So there is a homogeneity within, but then there is a difference between an undergrad student and a doctoral student. So right now in cluster sampling, something opposite happens. A classical example of a cluster sampling is, let's say for instance, if you were to study characteristics of a typical village in any rural part, let's say in rural India, you will find that if you take 10 villages, you will find all these 10 villages will be more or less identical in its characteristic. In the sense that there will be some poor people, there will be some middle class people, there will be some well-off people. There will be a hierarchy within this particular thing. There will be, let's say, a village headman, and there will be whatever systems are. A village will have some characteristics of people, of their socioeconomic characteristics. Okay, so that village A will be identical to village B in a certain region. If you look at a wider area, okay, in a particular state, if you look at it, so you will find there are several villages, and each of those villages will have certain characteristics, and each village, those characteristics will be identical to another village in the neighborhood. Right. So within each village, there will be a lot of heterogeneity. So there will be poor people, middle class people, rich people. There will also be a class structure. There will also be an administrative structure, and all of these things will get replicated in the neighboring village also. So each of this village within itself, it will have a lot of homogeneity, but largely you can say each of this village is actually a representative of the other village also in a lot of ways. So if you want to do a study, instead of choosing to study 25 villages, if you take 3 villages and study, you can safely say that, yeah, what is true for these 3 villages is also true for the remaining 22 villages. Right. So cluster sample is used wherein you have the situation wherein you have several clusters. Each cluster will have a certain characteristics. Within the cluster, there will be a lot of heterogeneity. However, all the clusters are homogeneous. I hope you get this point. Okay, each village, each of these 22 villages or 25 villages will be alike. However, within the village, there will be a lot of heterogeneity. There will be a lot of, like I said, socioeconomic. If you look at it, there will be a lot of divisions. Some people will be doing something, other people doing something else, other people will be, so that sort of thing you will find. So village 1 will be same as village N will be same as village N-1. So that heterogeneity that homogeneity will be there. So in these kind of conditions, instead of going and studying all villages, let's say there will be 100 some villages, 150 such villages. So it is sufficient to study 5 villages, come to conclusion and say that because this is true for 5 villages, it's also true for the remaining 120 villages. Right. So cluster has got that that's this particular property. Now this is actually in contrast with the strata that I was talking about. In strata, what happens is all the undergraduates are deemed equal, all the graduates are deemed equal, all postgraduates are deemed equal. Right. So there is a clear strata within the population. Right. And there is a homogeneity between this, but further there is going to be let's say within the strata there is going to be a difference, right? So anyway, I will be explaining a little more. So just wanted to make give opening comments about all these 4 methods. Now, probability sampling techniques, 4: simple random, systematic, stratified, cluster. So now let's look at all of these a little more detail. In simple random sampling, each element in the population has a known and equal probability of selection, right? Which is why the most classical example of simple random sampling is put all the names in a chit and then pull out whatever number of samples that you want, right? Each possible sample of a given size n has a known and equal probability of being actually selected. This implies that every element is selected independently of every other element, right? Classical example of random sampling. Now, how is this done? And a graphical illustration of this. Select 5 numbers from 1 to 25. The resulting sample consists of population elements 3, 7, 9, 16, and 24. Okay, so these are 25 random people, and you have randomly picked up numbers, and those happen to be 3, 7, 9, 16, and 24. Right. So what they're trying to say is there is no element from group C. So there is group A, there is group B, there is group C, group D, and group E, and 2 have got picked up from B. And that is purely random. That is not by design. Right. And there is nobody picked up from group C. That is also not by design. That is just random. Because when you randomly take people, somebody will get eliminated, some people, in some groups, 2 people will get selected, and so on and so forth. So this is an illustration of simple random sampling. Now, systematic sampling. So in systematic sampling, the sample is chosen by selecting a random starting point. So the first guy you choose randomly, and then picking every ith element in succession. Right. So first you pick the first guy, and then every 12th or every 15th or every 20th, depending upon what is I is. Now the sampling interval I, that is determined dividing the population size by the sample size. So like I said, out of 60 students, if you want a sample of 5, you divide 60 by 5, you get 12. Therefore, you pick up the first guy and keep adding 12. So that is how you get the value I, and by the time you get the 5th guy, the entire population gets covered once. Is it clear? I mean, is it confusing? I'm finding just lack of. You're clear about what is going on? Yes, see, you joined late, which is I'm asking you.
It's clear, sir.
It's clear. Yeah, Antara?
Yes,
Unmute.
sir.
Yeah, it's clear. Okay. Yeah, Rahul?
Yes, sir, it's clear.
Yeah, Ravish?
Yes, sir, it's clear.
Ansh? Ansh Gupta?
Yes, sir. Yes, sir. Yes, sir.
Okay, okay. Have you guys studied this previously, or this is the first time you're hearing this?
First time hearing.
First time. Okay, fine. It's clear so far, right, Prajwal?
Yes, sir.
Okay, great. Okay, let's move forward. Yeah. So in systematic sampling, pick the first element randomly and then use and add I. I is actually the sample. It's an interval which you actually obtain by dividing population size by the sample size. Right. So I was illustrating. Pick up the 7th guy first and then keep adding 12 or 15 or whatever till such time you cover the entire population, and you will get your 5 members of your sample. Now again, illustration of that. If the ordering of elements produces a cyclical pattern, the systematic sampling may decrease the representation sample. Okay, so basically the whole thing is, if it's coming to a cyclic thing, let's say the first element happens to be 37, so 37 plus 15 becomes 52. So 52 plus 15 becomes let's say 67. So 67 means come back to the 7th element. 7 plus 15 again becomes 22. So the whole thing. So if it becomes cyclical, you come back to the starting point. That's what it means. Okay. Illustration of this. of the systematic sampling technique, select a random number 1 to 5. So you say 2, and then after that you keep adding 5 to it. So first you take 2 and then you add 5, you get 7, 7 plus 5, 12, 12 plus 5, 17, 17 plus 5, 22. And that way you get all the required sample, all the members of the sample. Okay, so yeah. So okay, now we're coming to stratified sampling. Stratified sampling again, is a two-step process wherein whatever ratio or whatever distinctiveness is there in the population is also captured in this sample. Distinctiveness in the sense that there could be some distinctive characteristic. It could be in terms of level of education, could be in terms of gender, or some other criteria. So that criteria, that distinctiveness should also reflect in your sample. Okay, let's look at it. Stratified sampling is a two-step process in which the population is partitioned into subpopulations or strata. So this strata subpopulation division is based on that distinctive characteristic. Okay, the strata should be mutually exclusive and collectively exhaustive in that every population element should be assigned to one and only one stratum, and no population element should be omitted. So when you divide it like this, you should ensure that when you say girls and boys, so you should not have a situation wherein nobody's falling into either girls or boys situation, or everybody should be falling into one of the strata. The entire population should be divided in such a way that nobody gets left out, or that no one actually appears in two groups. Okay, that is one. Yeah, and so next, elements are selected from each stratum by a random procedure using simple random sampling. So first you divide the group into distinct strata, that is, by what course they are doing. They're economic student, whether they're the mathematics student, they're science student, arts student, commerce student, management student, whatever. So after that, it should be like each student be assigned to at least one. Right, nobody should be left out. All of them should be there in one group, and then your sample should also have these whatever small divisions subsequently. So that is how it is. So the strata should be mutually exclusive and collectively exhaustive in that every population should be assigned to one and only one stratum, and no population element should be omitted. Next, elements are selected from each stratum by random procedure, usually simple random sampling. Once you divide it into different strata, then you can perhaps use a simple random sampling, or you can use a systematic sampling or whatever to take elements of that population. So a major objective of stratified sampling is to increase precision without increasing cost. Okay. Now the elements within the stratum should be as homogeneous as possible, but the elements in different strata should be as heterogeneous as possible. So this was the point I was talking about earlier. So when you divide it into groups, make sure that postgraduate students are bundled together, graduate students are bundled together, doctoral students are bundled together, undergrads are bundled together. Right, and within that bundling, all of them are deemed to be homogeneous. All of them will be having identical characteristics. And the stratification variable should not be closely related to the characteristic of the stratification variable should also be closely related to the characteristic of interest. Finally, variables should decrease the cost of stratification. Okay, so same thing, if let's say for instance, if you are typically the stratification is done based on gender, because one is interested in knowing what is male preference, what is female preference, what percentage of males are likely to do this, what percentage of females likely to do that, and all of that. So whatever is there in the population, that same ratio, that same proportion should also appear in the sample. So that is the whole idea of stratified sampling. Now cluster sampling. So illustration. Okay, yeah. So in the illustration here, randomly select a number from 1 to 5 for each stratum. So the resulting sample consists of population elements 4, 7, 13, 19, and 21. So basically you're saying A is one strata, B is another strata, C is another strata, D is another strata, E is another strata. So there are 5 different strata here, A, B, C, D, E. You need to make sure that at least one is picked up from each of them. So from A you get 4, from B you pick up 7, from C you pick up 13, from D you pick up 19, and E you pick up 21. Right? So once you do the strata, you can do a simple random sampling and pick up a single element from that. So that is illustration of stratified sampling. Let's look at cluster sampling. In a cluster sampling, a target population is divided into mutually exclusive and collectively exhaustive subpopulations or clusters. Then a random sample of clusters is selected based on probability sampling techniques such as a simple random sampling. So basically, the whole concept of cluster is this. The clusters would be homogeneous, but within the cluster, there will be a lot of heterogeneity, right? So there are two ways of doing this. Either you can study one cluster itself. You can study a village itself and say take all the elements of that particular village and say that, okay, I've studied this village and therefore this is true for the entire population in that area, in that wider state or in that wider province, right? Or you could study 2-3 villages and say, okay, because it's true for 2-3 villages, whatever characteristic or whatever findings I'm finding is actually true for the entire district or province or state or whatever, right? So you can make that conclusion. Now, they are saying sometimes in a two-stage process, you will identify a particular village, and within the village, you will also do a further some sort of a simple random sampling. And instead of studying all the members of the village, you will be within the village, you will be identifying some elements and studying them. So maybe you will be going to 5 different villages, and within those 5 villages, again, you will do a simple random sampling, pick up around 25 elements from each of those villages and study them. And then you come out with your report, right? So that is the whole idea of cluster sampling. So in cluster sampling, a target population is first divided into mutually exclusive and collectively exhaustive subpopulations or clusters. Then a random sample of clusters is selected based on probability sampling techniques such as SRS. SRS, simple random sampling. For each selected cluster, either all the elements are included, right? All the population of a particular given village is taken in a sample. That is a one-stage process, or sample of elements is drawn probabilistically, two-stage, in which means you identify a village. Within the village, you do a simple random sampling and pick up 25 people from village 1, and village 3 you pick up another 25 people, and village 17 you pick up another village, and so on, and then conduct your study. Right, okay. Elements within a cluster should be as heterogeneous as possible, but clusters themselves should be as homogeneous as possible. This is what I was talking about, right? So all the villages will be identical. Village A will be almost characteristic of the village A will be same as village C, will be same as village E, will be same as village F. But within the village, there will be a lot of diversity or heterogeneity. So I put that in a red box. The criteria for forming clusters are just the opposite of that of strata. Elements within the cluster should be as heterogeneous. Within the cluster, elements will be heterogeneous, but the elements within a stratum will be homogeneous. If you say one stratum, if you say all the postgraduates are alike. Or if you look at gender, all the girls are deemed to be alike. Right. So therefore, in a lot of ways, cluster sampling and strata sampling are seen as opposites or inverses of each other. Okay, graphical illustration of this. So randomly select 3 clusters. So selectors that you have clustered here is B, D, E. Of course, the assumption is that all clusters A, B, C, D, E are identical. Okay, you are saying A, B, C, D, E are identical. From that, you've randomly picked up 3 clusters B, D, and E. And within that, you have further gone for a simple random sampling, and you have picked up elements 7, 18, 20, 21, and 23. And that is how you get your all the elements for your sample. Any doubts about this? Basically, I've discussed 8 different kinds of sampling techniques, 4 of them probability samples, 4 of them non-probability. Probability samples, basically simple random sampling, stratified sampling, cluster sampling, and stratified sampling. Okay, probability samples. Non-probability samplings, what I discussed in the previous class, convenience sampling, judgment sampling, snowball sampling, and quota sampling. Clear? Right? 4 different kinds of probability samplings, 4 different kinds of non-probability samples. Okay. Let's move on. Okay, so these are basically strengths and weaknesses of different sampling techniques. So non-probability sampling techniques, convenient sampling, of course, the biggest strength of it is that it is convenient to administer this. The most convenient of sampling techniques, perhaps this is what you guys are also doing. Basically, you've prepared your questionnaire, you're asking your friends and circle, putting it on social media, asking them to respond. That is convenient sampling, right? Most easy to administer and least expensive, least time consuming, most convenient. Now, the problem, a weakness is that it is likely to have selection bias, because the guys you're going to reach out, all of them are likely to have similar characteristic as yourself, as in, they're also likely to be university student. They're also likely to have similar set of interests and passion and attitudes towards towards whatever survey you're conducting as yourself. So it is also likely to be a replica of what you're thinking, largely so. I'm not saying every single time, but because you're going to reach out to people who are similarly educated or who've got similar thinking process, simply because they happen to be in your age group and your circle. Right, so there could be a selection bias. Selection bias, sample not representative, not recommended for descriptive or causal research. So this can give you an initial input about a particular problem, but yeah, it can never be used for descriptive or causal research. Now, judgment sampling, again, it's low cost, it's convenient because you're using your judgment, and you're basically saying this person is likely to more about this topic, so let me use him as a respondent. It's not time consuming. Judgment sampling, again, the problem is you cannot generalize it, and it is subjective. Why subjective? Because it's your judgment. So anything which is based on one person's judgment becomes subjective. It's never an objective thing. Okay. Then quota sampling. So strength advantage of quota sampling is sample can be controlled for certain characteristics. If you think that level of education in the university is going to affect their opinion, if they're more educated, they're going to have a certain opinion on something. So then you will be able to control it. You will be able to take the sample in such a way that this particular level of education difference is also reflected in your sample. Again, selection bias, no assurance of representativeness. So that is the disadvantage of quota sampling. Let's look at snowball sampling. Okay, one of the biggest advantages of snowball sampling is that one can actually estimate rare characteristics. As it is, you go for quota sampling because it's difficult to find guys who typically, as in, say, for instance, somebody's interested in Bitcoin, somebody's interested in mountaineering. So it's not very easy to find these kind of guys. So you'll have to go to the first guy and you will have to find details about the second respondent. So when you do that, you will sometimes find interesting insights which you otherwise don't get. You can estimate rare characteristics because these are people you will not find. If you do convenient sampling, it is very difficult to find a guy who is doing Bitcoin trading. Right. So these are guys who are little different from the rest of the population, but interacting with them, you will be able to unearth a lot of rare characteristics. Disadvantage, obviously time consuming because you have to keep looking for this fellow. Convenient sampling is, you can keep going. First guy comes, you take the interview, and the next fellow comes, you can take his interview, and then 10th fellow comes, you can take his interview. But here in this case, you have to keep looking for this fellow because first guy, you interact with him, and then that fellow will tell you where the next fellow is. So you have to keep looking for that fellow, go personally visit him or whatever, meet him on the, because it's a particular individual, right? You have to track him, trace him, and interact with him. So it becomes time consuming and a little cumbersome also. So those were the four non-probability sampling techniques. Now we'll come to the probability sampling. Simple random sampling, of course, very easily understood. Results are very easily projectable because you are taking a representative of the population, and then, however, it is difficult to construct. Sampling frame expensive, lower precision, no assurance of representativeness. Again, issue with this is, if you want to study, let's say the population of Sri Lanka, it's very difficult to take all the population register, put all 2 crore people, and then do simple random sampling and identify all this whatever sample 200 people out of, or let's say 10,000 people. In theory, it's actually very difficult if you're doing it for a large population to ensure that all of them are actually covered. Right. For a smaller population, maybe, if your population size is around 500 or something, maybe simple random sampling is practical. However, if you're studying huge population, of a large Asian country, it is impossible to do it. All right. Okay, systematic sample. It can increase representativeness, easier to implement than simple random sampling. Sampling frame not needed. Again, one of the disadvantages, it can decrease representativeness. Let's move on. Stratified sampling. Okay, so biggest advantage is that you are taking into account all the subpopulations or any specific characteristic which stands out within the population. You are ensuring that that is also reflected in your sample. And again, weakness is difficult to select relevant stratification variables, not feasible to stratify on many variables, sometimes expensive. So sometimes you may not be able to really stratify this. So you may, in your research from the general population, you may want to do studies like, people who are diabetic, people who are not diabetic, right? So how are you going to find out the people who are diabetic? How are you able to determine this? But maybe you want to know this because you are doing a health survey, right? You want to study effects of, let's say, diet or um, maybe yoga or any of those health related things, or a health drink perhaps. So you also want to get a sense of what people with sugar problems have, let's say diabetics or non-diabetics and all. So you know that there will be a difference in the response, but how are you actually going to do it? Right, gender, male, female, it's easy, but then this kind of thing becomes tricky sometimes. You may not be able to get that stratification right. Okay, and lastly, cluster sampling, easy to implement, cost effective. Second, the disadvantages are imprecise, difficult to compute and interpret results. Okay, let's move on. So which of these would you choose? Would you choose non-probability or probability-based sampling? Again, some criteria. There are some conditions which favor the use of non-probability sampling and others which favor the use of probability sampling. So if the nature of research is exploratory, right? If you're doing an exploratory kind of survey, it actually makes sense to do a non-probability sampling, right? However, if it is conclusive, invariably you have to go for a probability based sampling. You have to, because if the study has to sort of be conclusive, and if you have to say very firmly that, yeah, this findings is true for the entire population and I am 95% confident or 90% confident or whatever, you cannot do it based on judgmental sampling. It has to be necessarily based on one of the probability sampling techniques. Relative magnitude of sampling and non-sampling errors. So non-sampling errors are larger when you do non-probability based samplings, and these are sampling. However, sampling errors are larger in the other case. If the variability in the population is low, you can actually go for homogeneous. If it's a homogeneous population, you can go for non-probability sampling. If it's a heterogeneous population, if there is large variation among the elements in the population, you can go for probability sampling. So statistical considerations, generally it's favorable for probability sampling because that will be more robust when you take out all your statistical tools, whereas statistical considerations not very favorable for non-probability sampling because there could be inherent biases and it's not truly representative of the population. Operational considerations, it's easy, it's quick, it's favorable. That is non-probability of, to implement and to actually undertake the survey. It's a lot more convenient and easy to do non-probability sampling, judgment sampling, convenience sampling, and so on and so forth. However, operationally, it's difficult to do the probability sampling. So here is a conceptual map of sampling techniques. So sampling techniques are two. Basically, this is actually the revision of whatever we have done. Sampling techniques are of two kinds: probability sampling and non-probability sampling. So probability sampling is selection based on chance or the principles of mathematical probability, whereas selection based on convenience or judgment. Okay, when you select based on your convenience or judgment, you basically employ non-probability sampling techniques. So under non-probability sampling, there are four broad classifications. Convenient sampling, sample based on convenience of the researcher, and basically you are choosing a respondent simply because the respondent happens to be at a certain place at a certain point of time. So that is convenient sampling. Second is judgment sampling. So in judgment sampling, the researcher is actually choosing a particular respondent because according to the judgment or according to in the researcher's mind, a particular respondent will be able to give good inputs about whatever he is studying, right? And therefore you reach out to a particular respondent because that information in the researcher's mind is valuable. In quota sampling, of course, what you do is there is a certain classification, there is a certain ratio in the population. So you will ensure that that ratio of characteristics is also maintained in your sample. So typically gender or education level, whatever. And in snowball sampling, what you do is identify the first respondent, and from the first respondent, you are able to identify the subsequent respondents. So, one person leads you to another. Now, under probability sampling, again, there are four divisions. The simplest and the most widely or simplistically understood is what is called a simple random sampling. So in this technique, every respondent has an equal chance of getting picked. Each element has a known and equal probability of getting selected for being the sample. In systematic sample, you pick the first one randomly, and every ith element is subsequently selected, and this I is actually calculated as population size divided by sample size. Then you have stratified sampling. In stratified sampling, there will be a certain classification, either based on gender or education or any other unique characteristic, and those characteristics should actually reflect in your sample also, right? And lastly, cluster sample. Cluster sampling is used wherein when you know that there is a representativeness of the population, as in let's say each of these samples are occur as clusters, wherein the clusters are homogeneous, where within the whole cluster, each cluster, there is a lot of heterogeneity. So if you have a situation like that, you employ the cluster sampling technique. A random sample of clusters selected based on sometimes on a two-step process. So within the cluster also, initially you identify the cluster, and sometimes within the cluster you do a simple random sampling to identify some elements of that particular cluster. So that is actually a brief sort of about all the different sampling techniques we studied. Any doubts, questions? Okay, so shall I move on to the next topic then? Okay, great.